So that one more force is friction force. Friction force, I'll be introducing this to you very briefly so that we just get started. Later on, I'll be teaching you this friction force after a few topics separately, and it requires some time, it requires a specific focus. So here I'll be introducing you friction very briefly in order to help you understand, as I told you before, why normal reaction is always normal to the surface. So that is the my focus now, to just introduce you here. After teaching you this friction a little bit, we're going to solve some problems, get handy with whatever we have been studying now, and then after that we'll take it up again. Okay, so friction force, let's try to understand this. There's a block kept on the floor. It's a heavy one, not very light. So you come and you apply some force to it. The block doesn't move. You are applying some force, but the block doesn't move. Suppose you were applying a force of 0.5 Newton. The block is not moving. Right? Now you increased your force to 1 Newton. The block is still not moving. You have increased your force to 2 Newton. The block is still not moving. 5 Newton, still not moving. 10 Newton, it began to move. Now first thing to understand is as to why when you were applying some force lower than a minimum value, the block was not moving. What was preventing it from moving? If you try to look at the forces acting, you were applying some force. So if at all it is not moving, then the net force on this should be equal to 0, as per Newton's first law. If it is at rest, it will continue to be at rest until there is some net external force applied to it. And it does continue to be at rest. That means there is no net external force being applied to it. So you are applying some force, so there must be something that must be cancelling your force to make the net external force 0. And of course you know it. The force is between the block and the floor, and that force is called friction force. So friction force is applied opposite to the direction you are applying force. So friction force is the one that is opposing this force, and when you were applying 0.5 Newton of force, the friction force was also 0.5 Newton. So the net external force was 0. When you applied 1 Newton of force, the friction force also became 1 Newton. So again the net external force was 0. When you applied 5 Newton of force, the friction force also became 5 Newton, making the net external force 0. When you apply 10 Newton of force, then the friction force cannot go on indefinitely increasing. There's a certain point at which it will become constant and not increase anymore. So at that point, the block will start to move. That's how friction force acts. Now let's try and peek into the molecular level as to what must be happening there. Now, as you would understand that the surface, no matter how smooth it feels to you, at microscopic level, it is not smooth. There are spikes in the surface depending upon the roughness which the surface has. The surface actually at microscopic level is something like this. This is the floor at microscopic level that the block is kept in, and the block is not smooth either. The lower surface of the block will have spikes of its own. Maybe it is like this. And when these two are kept together, there is some interlocking between the spike of this surface and spike of this surface. Maybe the interlocking is like this. So this is the block and this is the floor. So they are actually locked. The spikes of the both surfaces are locked into each other. So when you try to move it, it doesn't move very easily because there is some force of repulsion from these interlockings. You have to break these interlockings in order to move the block forward. Unless you apply a minimum amount of force that will be able to break these interlockings, the block will not move. So friction actually is this. This is the interlocking between the two surfaces. That's why the friction exists. So when you apply certain amount of force, these two presses each other. When you apply certain amount of force, these two interlockings will press each other like this. When you apply more amount of force, it will tend to bend. but still not broken. So still there will be some resistive force for the block to move. When you apply more amount of force, more and more, this bending will break. It breaks from here. This spike and this spike, they broke. Now actually the block will be free to move. Now it can slide on this broken spike and they can move forward. So unless you break these spikes, the block will not move, and this breaking will occur at a minimum force. So you have to apply a minimum amount of force for a body to move on a surface where there is friction. So this is what goes on at molecular level. So this is why friction exists. Okay. So this is the initial introduction of the force that is there between two surfaces, and it will always be there between these two rough surfaces, and this is how the friction works. You have to apply a minimum amount of force for the block to move. Now this is why there is some loss of mass whenever there is friction, and that is why when two surfaces are constantly rubbing each other, there is some loss of mass invariably. For example, the wheels of the vehicles, they tends to become thinner and thinner as the days passes, because there is some loss due to the friction between the wheel and the floor. Similarly, the sole of your shoe, your slipper, they all become thin over the period of time. The machinery parts, they wear out over the period of time. Because of friction, there's some mass loss always. Whenever there will be friction, there will be some mass loss. This is the force of friction. It keeps on increasing to a certain level. At the point where the spikes break, it becomes constant, or the value decreases to a certain amount. At that point, the breaking point comes and the block moves further. So we're going to take this discussion further later, but for now, this must be sufficient for us to have a little bit of feel of friction. Okay, so that was a friction force. Now, the purpose of introducing this force now was this. I told you when I gave you this example, suppose this is a ladder or a stick kept on surface and wall like this. I told you the normal reaction will always be normal, and that's why it is named normal, because normal in physics means perpendicular. And similarly here, the normal reaction will be perpendicular to the wall. And I told you I'll tell you later, and now the time has come that I fulfill my promise. Now try and understand. Suppose the ladder is kept like this. Suppose this is the surface and this is the ladder, and the ladder is pressing the surface like this. Now see, if this is a smooth surface, first of all, it will be difficult to stay for the marker or the ladder to stay on the surface. It will move, right? The reason it will move, because there is little friction acting on it. If there is no friction, there is no way it can stay. We will analyze that later. But now the task is to understand why we are always taking this force perpendicular. Suppose the force is not perpendicular. The net force from the floor, and of course net force will not be perpendicular. Suppose the ladder is pressing the floor in this direction. So the floor will also be opposing that press and apply in return some force to the ladder in this direction. Now in the chapter of vector, we understood that it is very convenient always to break a vector into components, horizontal and vertical, because it helps a lot. So what we are going to do is we are going to break this force, one horizontal and the other vertical, like this. So this is the force that the floor is applying on the ground, and this one will always be vertical, because we have broken the force into component, one horizontal which will be parallel to the surface and one perpendicular. So this is the force that we call normal reaction, because it is perpendicular. This component is perpendicular. There will be some other force acting horizontal parallel to the floor as well, and that will be friction, as we saw a moment back. Friction is the force that is always acting parallel to the surface, because there are certain spikes on the surface and it has to break that spike. So friction force has to do with the roughness of the surface. It is always parallel to the surface. So whatever the force is acting on the ladder, it will be broken into two components. One will be friction and the other will be normal reaction. So in order to show the normal reaction, you will always draw a perpendicular line, and that will be your normal reaction. Whatever is perpendicular to normal reaction, that is the component of force which is friction. So friction and normal reaction both are being acted on the ladder by the floor. Okay, so the net force could be in in any direction depending upon the magnitude of friction and normal reaction. So the reason why we make normal reaction always perpendicular, because it is the component of the net force which is actually perpendicular. So we make it perpendicular, and friction and normal reaction are perpendicular to each other, so they are independent of each other. Normal reaction will have nothing to do with the movement in horizontal direction, and friction will have nothing to do with the movement in vertical direction. We had this discussion before, and it is very convenient to break a force into two perpendicular components. That's why we always do it. And the component parallel to the surface is friction, and the component perpendicular to the friction is normal reaction. That's why we make normal reaction always normal to the surface. Okay? Did you get this? Now let's have a little bit of more discussion to have a little bit of more insight. Now suppose you try and think of this. Suppose the friction surface is smooth. It is absolutely smooth. There is no friction at all. There is no spikes at the molecular level. It is perfectly smooth. Then can the stick or the ladder could be kept in this position? Is it possible? Think about it. Draw the forces which are acting on the block, and this is not smooth. This one has friction. Suppose this one has friction. It may be smooth, it may not be smooth. But this one is goddamn smooth.